Good morning. Much better? Okay. So my name is Harold Verley. I'm a senior solution consultant at Progress, based out of Europe. Been with Progress quite a while. Joined the Corticon organization in 2007. I was actually part of the acquisition of Corticon back in 2011. So it's been a long road with Corticon. Very exciting product. You hear it a lot during the conference. And you also heard from the keynote speech this morning that innovation has not stopped in Corticon. In fact, it's actually accelerating to a large extent thanks to Jim and his team. You heard Dimitri and Jim talking about Corticon for JavaScript, which is going to be released by the end of this year, which is a fantastic innovation. But another extremely great innovation is actually the ability for Corticon to connect up to REST services to pull in data. And that's going to be the topic of the conversation for this morning. Prepared a little agenda for you guys. So first of all, I'd like to talk about why is it important that Corticon actually needs to connect to APIs, right? Why does Corticon need data to actually, make or facilitate decision making in general? We'll also talk about the technical implementation. How did we do it? So you've heard a lot of talking about ARC, which is the autonomous REST connector that our folks at the DataDirect site made available in January as a first release. Well, the good news is we built that connector into Corticon. So we're now being able to actually connect through SQL to a REST endpoint. So that's what we'll be showing you during this presentation. I'll also be showing you ARC, just plain ARC. How does this work, in combination with a REST endpoint, and how can we query that data source? And lastly, obviously, I'd like to finish with some roadmap items, some likely candidates that we're looking at to actually build into Corticon as well. And I actually encourage you to come afterwards, after the presentation, towards me just to talk about what you see, what could be important that we put into Corticon as well. So let's just hit it off. Well, I guess we've all noticed the rise of the API economy, as we call it, right? More and more we see that everything is basically positioned as a service. So if I want to get around in town nowadays, actually from Amsterdam, right? So if I want to get around in Amsterdam, parking my car is extremely expensive. So it's actually better to actually park my car outside town, just shuttle in with the metro or the bus, and then take a little step just to get around. So the only thing you have to do is actually, register for that particular service. You've got birds and limes, you've got all kinds of names, and walk up with your app to this little step, and then just push a button and initiate the rent for a very short duration of that particular vehicle. Uber is another example. I mean, so there's so many examples where businesses actually, allow you to kind of tap into their products or services via apps. Now, that has, some very serious implications on the back-end infrastructure. Because, we used to actually do everything kind of on the inside of our company, inside the firewalls of our company, processing sales orders, doing manufacturing, whatever it was, really inside the confines of our firewalls. But now suddenly, because we are starting to extend, our product and services to the outside world, and we expect people to actually consume those products and services through apps, we need to actually open up our IT infrastructure as well through APIs. And it's what we call breaking breaking apart the monolith, putting all these different, services that we have, like billing services, how can I book a particular asset, like a taxi, or the management, even financial services, etc. So we kind of need to expose all of that to the outside world. And so what we see happening is that more and more companies are building microservices, and on top they build APIs to actually allow, external parties, certainly with a certain level of security, to tap into those services. Sure.
Should I hold my questions, or should I?
No, go ahead.
So can you define microservice, like in that respect, line service, where they just wait for that particular vehicle available?
Mm-hmm.
Is that an example of a microservice to you? In that example right there.
That could certainly be an example of a microservice where, still the backend registers those orders, those bookings. There is an associated financial transactions with it as well, maybe involving third parties. All of that can be packaged into services, essentially atomic services that are then exposed in apps and consumed through apps.
So would you say the entire thing, let's say managing the user, managing the transaction, is a service, or would each of those be a microservice?
No, each of those would be, atomic services that, based on the need at a specific date and time, or a particular user, particular service offering, is going to be utilized.
Okay.
All right? Yep. So we see also this reflected kind of in the growth of public APIs, right? So it's kind of exploding. More and more services, more and more data is becoming available publicly. And this is the public APIs. So you kind of see the growth. Literally in 2018, was one of the latest surveys with something like 20,000 public APIs available on the web. Actually, I will be leveraging some of those APIs in my demonstrations today. But this ignores the fact that there are literally hundreds of thousands of internal APIs that companies put available as well, that you can access, based on the proper credentials and what have you. So we've seen this explosion of APIs, REST-based APIs, to enable new services. And CTOs actually confirm that in order for their companies to actually survive and thrive, APIs are absolutely essential. Certainly integrating APIs into their ecosystem of apps is essential, right? If I rent that little scooter or step or whatever it might be, I might tap into Google Pay, Apple Pay, or whatever the payments service is. It's an example of an API, a financial API that is leveraged in that app, right? And it's critical that those services are exposed publicly to be consumed. So we recognize the fact that Corticon also needs to integrate with those API data sources. Now, over the past, I would say, 10 years, Corticon has had excellent data connectivity options, really focused on connecting to internal data sources, right? Relational data sources. So the initial capability that we actually built into Corticon was EDC, which was the Enterprise Data Connector. It was actually subject of the topic of my workshop that I did here on Monday with quite a few folks. So the Enterprise Data Connector was really focused on augmenting the data of single transactions by looking into a data source, a relational data source, to say, well, I received, for instance, this claim ID. What is all the other data that go with that claim? Because I need that data. For example, the claim amount, the type of claim, the damage, on my car that that happened, so all kinds of information that I need to actually process that claim, to adjudicate that claim. That was ADC, right? Single transaction enrichment, as we call it. And then later in, I would say 2017, we came up with the advanced data callout, really to process large volumes of data, again, based on accessing one or multiple data sources that usually live internally in the enterprise. So those were great and absolutely stunning capabilities, which, you know, we had a lot of success with in different industries such as healthcare, banking, pharma. You know, we have examples where we process literally tens of millions of claims. I mean, the state of Ohio, which was the episode of care use case that we discussed yesterday in one of our workshops, was a typical example of that. So great, but internally focused in many respects. Now, there might be a lot of reasons actually why you cannot connect to a particular data source, right? You may, you know, deal with multi-tenant data access, for example, which is complicating things. So if you connect with JDBC directly to a database, well, you get access to the complete set of data, right? So if you're dealing with a multi-tenant database, it's a little tricky. Perhaps you want to, you know, put on top of your database some kind of service layer, data access service layer, that prevents your users to actually get access to the full data in your database. You might have regulatory compliance requirements or quality of service concerns. Think about the fact that a user launches a query to your database pulling back like 10 million of records. What does that do to the uptime of that database for other users, right? It has a serious performance impact. The other thing is, you know, you might have an extremely complex technical schema. Building a service in Corticon, building rules against that complex schema is for business users kind of a daunting task, right? Very difficult. So you want to kind of have an abstraction layer on top of your database as well to actually say, well, you know, let's simplify this. And this is what kind of, you know, the data access we offer to our users, which is simplified and easier to consume. So, and the last thing I would say is sometimes there is no other way to access a database than through a service layer, through an API, because simply IT prevents you from kind of tapping into the database through ODBC or JDBC, which we used to do with the Enterprise Data Connector and the Advanced Data Connector. So, in conclusion, Corticon data integration strategy has been really focused on on-premise relational data sources, and we need now to extend out to either public APIs or internal APIs to actually address those problems that I just described. Okay, so back in, well, I was actually last year, we were actually looking for a solution. So we came together as a Corticon team and we thought, you know what, how can we enable this, right? How can we enable Corticon to actually access external data? We can build it ourselves, but that's going to be quite a task, right? And then suddenly, you know, what popped up was the DataDirect team that came up with this brilliant idea to put a piece of technology in place, which is called the Autonomous REST Connector, allowing you to consume a REST endpoint over SQL. So, brilliant, because, you know, Corticon already talks SQL, right? We have the Enterprise Data Connector, we have the Advanced Data Connector. They're all making use of essentially SQL, JDBC SQL. And this connector actually then allows us actually to, you know, using the same capabilities already present in Corticon to actually tap into that REST endpoint. So we said, let's try that. Let's give it a try. Let's build the ARC, the Enterprise Data, the Autonomous REST Connector into Corticon. So just to visualize this, conceptually from an architectural perspective, this is what the Autonomous REST connector does, right? It taps into all these data sources, whether it is big data, SaaS applications, operational databases, that expose REST APIs, whether those are big data, cloud APIs, or enterprise APIs, right? Internal APIs. And it allows you, using SQL through BI tooling as an example, but just plain query tools will do as well, using that driver to connect up to those REST endpoints and consume that data just with plain SQL, which we all know developers are used to, right? So we thought, Corticon would be excellent to actually leverage that capability, and then basically that exposes out all those public APIs to Corticon as well, to pull in data, for example, reference data. Let's imagine the case where you need to pull in, foreign exchange rate as an example, right, to calculate an order amount in a different currency. Let's think about a mortgage application where a credit bureau is consultant, or multiple credit bureaus are consultant for your credit risk. Those are all services that you want to leverage in Corticon for decision-making activities. You pull in that data, and then the decision engine can make a decision. So ARC has a number of key features. So first of all, it automatically maps JSON responses that you get from the REST endpoints to what we call an internal memory database representation. Okay? So JSON is fairly complex, can be extremely nested, etc. So what the ARC does, it translates that structure into basically a set of tables and fields. So it looks basically like a database. So a REST endpoint looks like a database, set of tables with relationships between them. It also does what we call heuristic sampling. So it figures out from the JSON response what data types are likely to be associated with each field in that JSON. So it will recognize the fact that there are decimals, strings, integers, and so forth in that request, response payload, which is brilliant because again, you've got many data types probably in that REST response. It also shows here on the slide, you can kind of push the filters that you want to use. You can push them to the REST endpoint. So in other words, your SQL where clauses, plain SQL where clauses, are actually pushed over to the REST endpoint by the driver. So as I said, it just offers a plain SQL support. I'll demo that in a moment. It obviously offers, authentication. Currently, ARC offers these 4 types of authentication, and I'm pretty sure that the list will be extended in the future as well as part of the roadmap of ARC. So just to be clear, at the moment, we support APIs that have JSON responses. And that is important. We'll come to that when we talk about the roadmap, because again, there are different types of JSON responses as well, but this is one of the most common one. We support parameterized APIs, either through the URL or as parameters in the request body. So the first one is really you put the query parameters in the URL that you're firing off to the REST endpoints. And secondly, you put the query parameters in the request body. So both modes are supported.
So if I understand this correctly, it would let you take 2 disparate data sources, allow you to do a join on those 2 in there, however you want, left. You can do inner SQL, left, inner, outer, cross, fine, right?
The answer is yes. I see Tony nodding his head. Tony is the architect on the ARC product in the back of the room.
And
That is absolutely true. Yeah, just.
do you, it's just basically, you have these disparate data sources that maybe are in, they could be in SQL, it could be any type of database, and you can just, I just want to make sure I understood that you can do joins through SQL across these databases, because the data comes back as JSON. It makes I just want to make sure I understood. That was my...
Absolutely.
Now, but it's not going to be atomic, because it's only read-only, right?
It's going to be read-only for the moment. Let's be clear about that. It's on the slide as well. For the moment, it's read-only. Roadmap, a likely roadmap candidate, is the fact that we will also support write support in the future. For the moment, so writes and updates, right? So inserts and updates. For the moment, read-only is supported.
Okay.
All right?
I have a second question.
Yep.
So, as you have all these disparate databases in different places, the speed of the network becomes important in certain times.
Yes.
Let's, an example might be that you have, and my question is about how to deal with this, when the speed is of the essence. So let's suppose you have a set of courses at a college, right? And let's suppose that everybody wants, let's say there's 1,000 students, and everybody wants this class, right? And so, and let's suppose there's a single wait list that is available for, say, some of the classes. You know, there's a table of wait lists for these classes.
Yep.
And students come in, and you have to get disparate data from multiple places, but you end up having to wait on a number of network connections. And let's say there's table locking, right? Because there's only one.
You complicate things, really. Yeah. Maybe Tony, you want to chip in because I see you waving your hand.
So
you kind of.
This afternoon, we're doing a double session on dealing with REST at the enterprise level. It's called the rest of the story. Myself and the product owner for ARC are going to be there. And what we're doing is, the whole session isn't just about ARC, but it's about dealing with REST at scale. So if you're interested, the reason it's a double session is because it's an interactive session, and we're going to take these detailed questions. I'm worried that the question might be out of scope for Harold's presentation.
Yep.
Thank you.
But we can answer those questions. Also, we're available at the booth during every break.
Okay. Thank you.
Yeah.
Thank you for letting me know.
Okay.
Just a curious guy.
No, which is good, really. Thanks for those questions, but absolutely, we'll handle them in your session or at the booth. There was a question in the back as well.
I was just going to ask you to repeat the question because I know there was.
Okay, thank you. All right, so let's continue. Yeah, let's take a look at this, right? I mean, and I know you guys are all geared up for the party tonight, right? So I wanted to get you in the mood, right? So we'll talk a little bit about beer. I know, I probably prefer to talk about coffee this morning, but hey, let's just start with some beer. Now, there happens to be a public beer API. Yeah, probably most people don't know this, but it's really interesting. So let's just explore that public REST API to connect to it and just do a little bit of a query against that data source. So first of all, so this is Postman. This is a REST tool, essentially open source. Most people probably know this. It's just, and as you can see here, we have an API, beers. It's on an HTTPS endpoint, which is pretty open because there's no authorization or whatever. I'm just gonna, send this to this REST endpoint, and you can see there is a fairly extensive response actually coming back, right? I mean, loads of beers. This is a Berliner Weisse with Jesu, whatever it might be, right? It's a Japanese citrus Berliner Weiss beer. Hope you can read it in the back. So there are lots of details associated with it, volumes, boil volumes, methods of production, temperatures, fermentation, twist, ingredients, hops, food pairings. So with what beer would you kind of match up this kind of this beer, right? What kind of food would be good with this? Brewer tips, et cetera, et cetera. So lots of information, lots of different data types as well, et cetera, et cetera. So I'm actually going to use another little open source database tool to actually launch a query against this REST data source. So hopefully you can see it a little bit in the back. Just give me a nudge if you can't. I'll zoom in, right? So what you have here in this tool is you can create aliases against a specific source, and obviously you have drivers that connect up to those data sources. And you can actually see that we also inserted the Progress ARC JDBC driver here. We also have it available for ODBC, by the way. So, but I use the JDBC connector. And if you look at the details here, you can see its name, and basically what you see, I referenced the driver's jar file here, the autorest.jar, which is the first release of ARC here as a driver. All right. Nope. Let's go back there. All right, so I created an alias for this particular REST API. So basically, I inserted the REST API. Now, this obviously there are a lot of driver properties that you can set for this particular driver. They're all exposed here in the interface. I haven't touched anything. I just, plain vanilla, just threw in the driver and connect to that driver endpoint. So I'll just connect up to it. And the REST endpoint that I just showed. So now here on the left side, you can actually see what is coming back from the driver. So this is part of the discovery process, and it actually comes back with a bunch of tables in the AutoRest schema. And the tables are, again, I'll zoom in, the V2 beers, the mesh temperature, the molds, the hops, the food pairings, all the stuff that you just saw in the response JSON, right? So, but now we have them as tables, right? And if I just click on V2 beers as an example, you see the colon names, right, that the ARC driver has discovered. So this is all the content, including the data types that have been auto-discovered by ARC. Brilliant. I'm just talking to a database here now. So let's do a query, right? Let's just do so I got several beer queries here. Let's just do a select all from beers. And this is obviously demo time. Why is that not working? Let's do this one. Let's just do a complex query, right? Select from beers the name as well as the alcohol percentage, and from another table, food pairing, the food pairing, obviously. So what food would be good with this particular beer? And obviously, I have an SQL where clause where I connect basically up both tables. And you can see I just pull back all the tables. You can see the different types of beer, their alcohol percentage, as well as the food pairings. So apparently a trashy blonde, 4.1%, goes well with fresh crab with lemon. All right? So very interesting information, right? All right. So you can see how easy it actually is to launch an SQL query against a REST endpoint. It's really a matter of minutes to actually configure this. And this is like really magic. Now think about it. We can use this in Corticon to pull in data, to augment the data of, for example, an applicant, a claim, whatever it is. That would be absolutely fantastic. So,
The Squirrel's open source.
Squirrel is open source, yeah. It's just a utility, nothing to do with Progress. Okay? All right, so we wanted to, as I said, enable ARC in Corticon. So again, as I said, REST is basically represented as an in-memory database, a relational database. You just saw that in the demo, right? And it's in Corticon, we actually implemented the reach out to that data as what we call a service callout. By the way, you guys all get access to the presentations and the recordings. Maybe not next week, but maybe the week afterwards. So don't worry about it. If you see some interesting material, you'll get access to it just after the next event. Okay? So the use of ARC in Corticon is actually very much the same as ADC, right? It's actually it's going to be part of the rule flow as a component in the rule flow that you configure for REST data access. It also allows you to tap in multiple REST data sources in one single decision flow. So if you want to reach out for a currency lookup or a credit bureau lookup at the same time, all in the same flow, it's all going to be possible. You can mix and match. You want to tap into your internal data sources at the same time in the same rule flow using SQL. You can use the advanced data connector. So you can mix and match. You can make it as complex as you want. The other nice thing is because we're talking to an internal relational database representation, we can use the same mapping capabilities that we already have available in Corticon to map to relational data sources. So that's going to be really easy as well and familiar to you as well, because most Corticon users that use or leverage this capability already know about this. All right, so from a REST capability, we allow you to import new entities. So for example, reference data might be a good example. I gave you the example of the currencies and the currency codes and currency conversions. It's usually a limited set of data, like, something like 50 or maybe 150 data elements that you want to pull into Corticon for decision making. And secondly, you can retrieve data to augment existing entities that you pass into a request payload. So for example, I want to apply for a mortgage. I'm an applicant, right? So my name is Harold. I probably live somewhere in a database or whatever. So when my mortgage needs to be processed, the unique applicant ID is my identifier, maybe it's my social security number, can be passed into the service. And the service, based on the REST API, will then use my social security number to look up all my details. Okay, so this is what we call retrieve, augmenting the data. Now, obviously, we support query parameters to actually launch, or inform the REST endpoint what data to give back. And there are different ways of passing those parameters. You can pass them as query strings and path parameters. So for the folks that understand REST endpoints, this should be understandable. Okay. So obviously, when we run a Corticon decision service, we want to pull data that is relevant, right? So just gave you the example. If I pass in my social security number, that social security number should be used as a kind of a substitution parameter in the query string to pull back my data, right? So we do dynamic parameter substitution as well. Yep.
Sorry, that dynamic parameter substitution, that can be parameter that's been derived by prior rules.
Absolutely. That's very good. So everything that lives inside Corticon working memory, whether it is determined by the rules, whether it is provided externally in the request payload, as an example, can be used as a substitution parameter. Very good point. Okay. So we already talked about discovery. Really, it's the process to infer the data types from the request payload. And you see an example here on the right side. We saw it in the demo as well. It's a heuristic process, right? So it's a best guess, so to say. But it's pretty reliable, actually. I'm really impressed by what the team did there. But sometimes, really, with very complex schemas, it might not be sufficient. So we also offer you to actually provide what we call a user-supplied schema. So in other words, you can do the discovery in Corticon, right? So the ARC will say, oh, this is a decimal, this is a string, and this is kind of the name for that particular field and so forth. You can export that file and you can edit it and re-import it. And we will then add that file to the vocabulary and use it during runtime. So you have a lot of control over this as well, which is a huge benefit. All right, so let's take a look at this, right? So this is another service I dreamt up. It's again a public API that we're going to use. We're going to, I'm going to give you some recommendations for some really good movies. Okay, so we're going to connect our Corticon vocabulary to IMDb, which is the internet movie database. Right, it's publicly available. We can import some data and map that to our vocabulary. So we have a match between the REST service and the Corticon fact model, the vocabulary that drives essentially our rules. Right. We obviously need to configure our rule flow because again we need to do that substitution. Right. So if I ask for a specific movie title, I want to pull only the information for that specific movie title. And then basically we'll run the service for you. All right, so that's what we're going to do here in this demo. So for those that do not know this service, IMDb, just type it in, imdb.com. Game of Thrones, I love that show. I guess everybody does, right? So that's just one example. But you can see there's a lot of information on the Game of Thrones that is presented very, very nicely here in this on this website. Now, from an API perspective, yeah, things look a little different, obviously, as you might imagine. So this is the API, right? It's omdbapi.com. There's a specific API key, which authorizes me to actually pull data. There is a movie title. T-title. So these are the kind of, query parameters, right, that we use to actually pull data, all right, from that REST API.
And the documentation for those would be on IMDb or be somewhere else?
So this is on IMDb, where you kind of register to get access to that particular public API, and it will give you examples of all the kind of query parameters you can use against that REST endpoints. And this is just one example, right? This is for movie titles. So if I launch this, again, I'm getting a lot of information back for that particular movie. Oh, sorry. All right, so I will not be showing everything, but there's a lot of information there, guys. I mean, really. So this is exactly what I just showed you on the webpage, right? But this is unformatted, raw JSON. So ugly, ugly. All right? All right. So, oops. So we actually want to, kind of see this in Corticon. So this is our service, right? So we get movies from IMDb. The yellow brick here in this rule flow, that is actually my REST callouts, right, that I just talked about. And then, the green blocks are essentially my rules, right? So if I click on recommend movies, oops. All right, so let's go there. So I'm actually in my rules based on my vocabulary, which is here on the left side, I'm actually calculating an average movie rating, and then, based on the average movie rating, whether it's under 6, between 6 and 8, and 8 and 10, I'm actually showing you a number of rule statements that are down here. Okay? So nothing complicated, but I'm just calculating an average rating based on what is coming back from the call. Now, for that, I need to configure, first of all, my vocabulary. In my vocabulary, I need to add a data source, a REST data source. All right? So you see that that has now been added to Corticon. Here on the tab that initiates that, I've defined basically the service. So let me just clear the schema. All right, so now I have access to the REST URL. The authentication is parameter token. Remember that I needed a token from the service. When I register, I get a unique token just for me that gives me access to that service. And obviously, we support the other authentication methods that were on the slide that I previously discussed with you as well. You pass in the API key, which is a secret key, obviously, and the query parameter, T, for title. And the title, by default, I just picked a movie title, right? June, whatever, all right? That allows me to discover the schema, right? And you can see it is automatically added to Corticon, successfully imported. And now I need to map everything to the entities, which is the movies, but a lot of information, as well as the ratings, as you can see, for that movie. So the movie will map to this particular table, which is the auto rest schema.rest data. You saw exactly the same in Squirrel. Remember that we had those tables, right? So this is the table selection. And obviously the table has colons like title or runtime or when is it released or where can we find information on the website and stuff like that, right? So these are all the colons that are available and map to a particular data type in the Corticon vocabulary. Now lastly, I need to configure the service, right? This little block in the rule flow, it has properties, and it allows me to select the appropriate method of import or retrieve. Now, I want to retrieve, because I launch a search title, and that search title needs to be complemented with the information that comes from IMDb, right? So that's kind of the service, the method I'm initiating, and it has runtime properties as well. It has a data source, obviously my IMDb REST service that I just defined in the vocabulary. It pulls the data and puts it in the movie entity in the vocabulary, and the substitution parameter will be the movie search parameter. Okay, so looking at this from a test sheet, I got 3 movies here, Pulp Fiction, Showdown for the Redemption, and June, and I can just launch that over here. The service will be compiled, takes a couple of seconds, and it will launch a REST call, augment the data, so in other words, complement the data on the entity with the search parameter and pull all that data from IMDb, including all the ratings for that particular movie that I then used to average up. And for each movie, I then provide a recommendation that you could see down here. All right, so the movie Pulp Fiction, produced in year 94, it's between brackets, so that's kind of coming from the service. And the Pulp Fiction movie is a great movie, you won't regret seeing it, etc. So that's the rules being triggered by the rules, okay? So this gives you an example of how easy it is actually to pull data into Corticon for decision-making activities. Oh. All right, so let's finish this up. I have a couple of seconds. We have a roadmap. We anticipate also supporting OData in the future, which is another REST flavor. Currently, we support REST over JSON. So just be aware of this. OData will be added, most probably as well, in the very near future. We're working towards that. For example, if you want to tap into Microsoft Dynamics, the only way to do that is through OData version 4. So we will be supporting that in the future. Dynamic user credentials will also something that will be possible in Corticon. So in other words, if you have a multi-tenant database, you want to pass in those credentials externally when you initiate your decision service, right? And those credentials are then being used for the data lookup, right? Whereas today they're static, tomorrow they might very well be dynamic. You saw the vocabulary. It's actually not automatically created off the data source definition. We anticipate that it's something that we can build as well. So actually populate the vocabulary, the Corticon vocabulary for you automatically based on the REST content. But it might, similarly, it might also be an internal relational database structure for which we auto-generate the vocabulary. There are some other stuff that we're working on, certainly on the Open Edge side, the JSDO as well, that we want to support, but I delegate that to Tony for his afternoon session, and write support that we already talked about. Okay? So with that, sorry guys, I overrun with 1 minute. Just like to point out there is a next session here as well, just after this section. So we would welcome you back if you're interested, and thank you very much.